Hello, this is Group 29. This operating system lab project has been created by students of ICT 19 batch by Mihir Shah, Nachiket Soni, Vidhi Patel, Pragya Priyadarshini, Om Gorakhya, and Aryan Shah. This is a Python based project and we have integrated CPU scheduling algorithm in this GUI. The disk scheduling algorithm and page replacement algorithm were already integrated by our seniors. We have used libraries such as tkinter, OS, pandas, numpy, subprocess, matplotlib.pyplot, and random. So firstly, what is CPU scheduling? It is a method that allows one process to use the CPU in efficient way while the execution of another process is on hold or in waiting state due to lack of resource like input output, thereby making full use of CPU. The operating system chooses the process for execution in the ready queue at the time when the CPU remains idle. The selection process is carried out by the short-term scheduler. The scheduler selects from among the processes in the memory that are ready to execute and allocates the CPU to one of them. We would be showing all the algorithms integrated by us in this GUI.
Hello everybody, this is Mihir from Group 29 and I'll be showing you our implemented CPU scheduling code. This is what our GUI looks like. We have implemented FCFS, SJF, RR, HRRN, SRTF and LRRN. I'll just give you the demo of FCFS. FCFS is first come first serve, so here whichever process comes first, irrespective of the burst time, it gets evaluated first. When you click the visualize button, the table, which has the details like arrival time, burst time, completion time, turnaround time, and wait time pops up, along with the graph, which gives a graphical representation of how the processes will be executed. Apart from that, we have a similar struct followed in every of the algorithm that we have used. And we also have this compare all args section, which will give you average turnaround time and average completion time of all the algorithms that we have implemented. Apart from that, we also have theory section where on clicking the particular button of the algorithm, you get a brief theory explanation and an example for the same. And then when you press back, you return to the main screen.
Hello everyone, my name is Nachiket Soni and I'll be giving you the overall code structure of this particular project. As you can see, I have a file named cpuscheduling.py open. This file contains all the implementations of the CPU scheduling algorithms that you saw earlier. I'll be providing you with an overview of what these files contain and what is being implemented in the respective functions. So first of all, as you can see, we are importing all the necessary libraries from line 1 to line 6. Then we have a definition of a function named theory, which basically calls theory cpu.py, which contains all the integration of theory images of their particular CPU scheduling algorithms. Then we have a class named table. This class is used for creating the tables that you saw in the GUI. Moving on to the function named FCFS. It is basically the first come first serve CPU scheduling algorithm, which is a non-preemptive algorithm. First of all, we initialize all the necessary information that we will be extracting using the algorithm. So there is CT, TAT, WT, and we are converting the ATBT string that we get from the GUI into integer types so that we can actually perform some calculations on them. Then from the line 45 to 50 ensures that the values of arrival time are in ascending order. Then from lines 52 to the line number 64, we have initializations for the Gantt chart that you saw earlier. Now, as you see, there's a for loop which basically implements the algorithm first come first serve. Here, we first check if the arrival time of the particular process is greater than CPU time or not. If it is, then it increments the time CPU value. Following codes of line basically calculate all the values that we initialized earlier and at the same time create the Gantt chart variables that are needed for the chart. Similarly, the lines that you see further help us to define the parameters of the graph that was seen and provide labels to it. Then the lines 133 to 139 help us to make that window of the chart as well as the table. Similarly, the algorithms have a similar implementation that you can see on our GitHub page. Then we have a function named visualize that basically integrates all the above algorithm into one particular function or wraps them into one particular function that we can directly call upon. Compare method basically runs all the algorithms so that we can compare their average TAT and CT from the lines 883 to the end of the file, we basically provide information and parameters for appearance of the GUI. Then we move on to the file named theorycpu.py. This file basically helps to integrate all the theory images into the GUI. All of them are defined in functions, and those functions are being called by these buttons here. Thank you.